And welcome back, friends, to Cajun Coding. Didn't have any uploads over the weekend. Took a little time, take it easy, and now we're back this Monday morning to go ahead and do more exercises on the Codingbat site. As we can see, we're in Array1 section, and we've only got 4 exercises left, so we should be able to comfortably finish that up in this video. And we're starting with front piece. Given an integer array of any length, return a new array of its first 2 elements. If the array is smaller than length 2, use whatever elements are present. And it seems pretty easy. Now, this does say return a new array. Let me see. So, for example, I'm pretty sure if we had just returned the array itself, if it happened to be exactly 2. Let's go ahead and check that out just to see. So if nums length just out of curiosity here, and it actually wants us to return an array. So let me see. Let's just do that. So we'll just return the array. Actually, it looks like the compiler doesn't recognize the fact that the array it's getting back is the same array that it passed in. That was just curiosity there. That really doesn't have anything to do with the exercise, but we learned something. So now, as far as completing the exercise goes, okay, now it does say if the array is smaller than length 2, use whatever elements are present. We did learn from that. So if nums is less than 3, we can just return nums. And if it's 3 or more, we can do how about this? And what I did find, I did some reading and actually found out that you can create an array and return it in one line of code. I tried to do that earlier and didn't quite get it, but what's going on here? Oops, it's nums length. Nums dot length. But in this case, you can create the array and return it in the same line of code. So what we've got here is we've got return new is going to instruct the compiler to allocate memory for an array, which is indicated by the brackets, containing integers, and then we use the curly braces here. Inside the braces, we can populate the array. In this case, the first and second values in the nums array that we received. And of course, it's 0 index, so it's indices 0 and 1. Now note, we have no name for this array. You can actually omit the name and just simply return the array if you do it like this. Generally, you're not going to want to be throwing around objects that don't have names willy-nilly. However, for a brief exercise like this, and that's okay. And if you if you have a limited scope function that's not going to be very persistent or something like that, it could be okay. So, but just be aware that that would be the formatting for returning an array, generating and returning an array in just one line of code there. So, and on to the next one. UnluckyOne will say that a 1 immediately followed by a 3 in an array is an unlucky one. Return true if the given array contains an unlucky one in the first two or last two positions in the array. Let me see. And the impulse is to use for loops a lot to iterate through arrays. It's absolutely a skill that's essential, and it's the easiest way to do things a lot of the time. Doesn't mean it's all the time, and in this case I think that just writing out the if statements without putting in a for loop. I think a for loop would be more work than it's worth, and it's over-engineering it. So this is going to be return type Boolean, so we're going to return true or false. Basically, we're just going to put our code checking, and if all of our checks fail, then we're going to have our return is going to be false, and then we'll put our checks up above that. So we're looking at the first two spots. So if nums 0 equals 1 and nums 1 equals, is it 3? Yeah, 3. Now we're going to have a couple of these statements. So we're going to use an OR, and for readability's sake, we're going to use a return so that we can have them one after another. Be a little bit easier to read. Remember, Java compiler doesn't see white space, so it's not going to realize that whether it's on this line or the next line doesn't really matter. So let me see, and we're going to have the second space equals 1 and now what about our ending space here? Now it says unlucky one in the first two or the last two positions. Now we can't have an unlucky one in the last position, because to be unlucky, the one has to be followed by a 3. If it's at the last position in the array, then obviously that can't be the case. So we actually only have to do one check, and that's going to be nums length. Okay. Now nums length is going to be the spot past the last index of the array. So if you have 3 spots, it would be 3, since it's 0 indexed, there is no index 3 if it's 3 long. So length minus 1 would be the very last spot, and length minus 2 would be the next to last spot, and that's the one we're looking for. So nums index nums length minus 2 equals 1, and the next one, nums length minus 1, is the very last spot, equals 3. Remember the double parentheses here, because that outer parentheses is going to enclose the if statement. We're using the inner parentheses to break up these checks, these logical checks, to make them easier to read. Now if one of those comes up as true, then we're going to return true. And we could do an else. We don't really have to. We could just leave it out of that, but if it makes it easier to read. Now we're not quite done here because we're not checking the length of the array. I'm not sure if they're going to have any short arrays here. And we can just use that. Let me see. For this one, we have to have an array length at least 2. So if nums length is greater than 1 and for this second one here, to check we need to be at least 3, so it'd be greater than 2. So, ooh, darn it. Let me see. I've got an extra if in there. Num's length is greater than 2, and this one would be num's length greater than 1, and that should do it, I think. Yeah, there we go. That works. UnluckyOne. MakeTwo. Given 2 integer arrays, A and B, return a new array, length 2, containing as much as will fit the elements from A followed by the elements from B. The arrays may be any length including 0, but there will be 2 or more elements available between the 2 arrays. So we are going to have at least 2 elements between the 2. However, we don't know how long the arrays are going to be. So if we do this, if a length equals 0, okay, so these are basically our 3 possibilities, right? So we've got a length equals 0, and we've got a length equals exactly 1, and then if it's not 0 or 1, then a length is going to be 2 or more. So a length equals 0, we're just going to return an array consisting of the elements in B. So B indices 0 and 1, and we know that we're going to have enough for both. We're going to have both of those because we know that we're going to have collectively 2, at least 2, to choose from there. So in this case, we're going to return. Now we know length equals exactly 1 in this case, so return uint. And since a length is exactly 1, we know that there's something there and something there. So that's what we're going to return. And otherwise return new integer array. And there we go. And front 11. I think this is our last one. Front 11. Given 2 integer arrays, A and B of any length, return a new array with the first element of each array. If either array is length 0, ignore that array. And I think that's the tricky part. If we know that the arrays are at least length 1, we just create an array and assign each of the first of those. The tricky part comes from the fact that in Java, arrays length is not variable. Once you set the array's length at its creation, you can't change the length of the array after that. So by ignoring an array, we're actually going to be returning a size 1 or a size 0 array. And that's what we need to check on. So let me see. Alright, so if A length equals 0 and B length equals 0. So if they're both length 0, and we know that they can be any length, so that is a possibility. So we're going to return a new array of integers I think we can just, can we just put 0 there? Because it would be length 0. I don't know, let's see how that works. Else, if A length is equal to 0 or B length is equal to 0. Now this is the caret, this is the exclusive OR, so this means that one of them is 0 or the other is 0, but not both. So that means that we're going to return, oops, I think we need another if. If A length is equal to 0, then return new int B. And I think that should work. Let me see. Oh, what we got? I think we're missing a bracket. What have we got here? New int. This should be closing the square bracket and then opening the curly brace. Yeah, that's it. Okay, so what we've got here, this looks like it's a little longer than it has to be. It's probably a more succinct way to do it, but this would be the naive solution, the easiest one to do. And what we've got is, if both of them are length 0, we're just going to be returning an empty array. And I was a little iffy about this line here. This line, the syntax is fine. We're going to return new, we allocate memory, an array of integer type, and then 0 inside the brackets here indicates it is of length 0. So the compiler does create an array in memory, but it contains no elements. Otherwise, if A length equals 0 or B length equals 0, one of them is equal to 0 but the other is not. If we know that one of them is not 0, then we just check the length of A and then populate our one element array with the first value in B. Otherwise, we populate it with the first value of A. Now, if neither of these are true, neither one of them are 0, then we're just going to grab the first one from each. So, easy peasy. And there we are with Array1. Finished with all the exercises there. I think I did have another solution. What's this? It says it's a more succinct solution for the front 11, because I was looking at that. It doesn't look like it's a much shorter. It's a little bit shorter there. Oh, what did I do? Did I copy it wrong? Let me see. Oh no, this is the wrong. That's the wrong one. That's not it. That was an alternate solution for another exercise. So, which one was that? It's the MakeTwo exercise. Let's see what we got here. Yeah, it's quite a bit shorter. Okay, so what we've got here, if a length equals 1, okay, so we can create a new integer array. If a length equals 1, then we know we're just going to put the first element of, with the only element of a, and then the first element of b. If a length equals 0, then we're going to return the first two elements of b, because there's nothing to take from a. Otherwise, if neither of those are true, then logically we're going to have two elements or more in a, and that's what we're going to grab there. So yeah, that is a more succinct solution than the one I came up with. But in any case, that's array 1. And let me see, should we go on to maps? We have a few minutes. Let's go on to logic, and I think we should be able to get a few out of the logic category before we run out of time here. So, Cigar Party. And now I'm advocating tobacco use, so I don't know how young the folks watching this are, but this is purely hypothetical since I don't think squirrels actually smoke cigars. When squirrels get together for a party, they like to have cigars. A squirrel party is successful when the number of cigars is between 40 and 60 inclusive, unless it is the weekend, in which case there's no upper bound on the number of cigars. Return true if the party with the given values is successful, or false otherwise. So let's go ahead and return false if all of our checks fail, and then we'll put the checks in there. So if is weekend, then there's no upper limit on the cigars. There presumably is a lower limit, so they need to be at least 40. So if cigars is greater than or equal to 40, return true. If that's not the case, then we'll go down into our default of false. If weekend is true, now let me see. Let's go ahead and do an else here. If the weekend is not true, if cigars is greater than or equal to 40 and cigars less than or equal to 60, return true. And if those all fail, then our default is false. And looks like that works. What's our show hint? One approach begins with is yeah, that's exactly what we just did. And let's see what their solution is. This is a pretty simple problem, so there's only so many ways you can return cigars. Else return cigars. Well, they've got a little bit more succinct here. Return cigars greater than or equal to 40 and cigars less than or equal. So it's either going to come back true or false. So yeah, I could have made that a little bit shorter. And next exercise, date fashion. You and your date are trying to get a table at a restaurant. The parameter U is the stylishness of your clothes in the range 0 to 10, and date is the stylishness of your date's clothes. The result, getting the table, is encoded as an integer value with 0 no, 1 maybe, 2 yes. If either of you is very stylish, 8 or more, then the result is 2, yes. With the exception that if either of you has a style 2 or less, then the result is 0, no. Otherwise the result is 1, maybe. Okay, so it looks like we really need to look at either of you has a style of 2 or less. So it looks like what they're describing, any value 2 or less is going to result in no. So if you less than or equal to 2 or date less than or equal to 2, return no, which would be 0. If either of you is very stylish, the result is yes. Exception if either style, let's see. Otherwise, the result is maybe. So else. So this else block will only execute if everyone is 3 or above. If, let me see, you greater than equal to 8 or date equal to and greater than 8, return yes would be 2, and then the maybe would be the other possibility there, and that's correct. What's our hint? If x returns 0, what's xxx? Compute with the date numbers. That's basically the pattern we just did. Yes, with the exception they used the else if and then another else, whereas we used if and then else and then nested if else within that. But it's kind of 6 of one, half a dozen of the other, so same thing. And I think we'll do one more here. The squirrels in Palo Alto spend most of the day playing. In particular, they play if the temperature is between 60 and 90 inclusive. Unless it is summer, then the upper limit is 100 instead of 90. Given an int temperature and a boolean is summer, return true if the squirrels play and false otherwise. So we've got our is summer. So if is summer, and we're going to use the rules for summer. And in order to be succinct, we can just return temp greater than or equal to, I believe it's 90. The upper limit is 100 instead of 90. Actually, it just changes the upper. So between 60 and temp is less than or equal to 100. And if it's not summer, the upper limit would be 90. I think that's it. And that's pretty simple. Now these are of course the introductory logic problems, so they're not very challenging yet. Things will get more complicated as we progress. I think we have time for one more. Caught speeding. You are driving a little too fast and a police officer stops you. Write code to compute the result and code it as int value 0, no ticket, 1, small ticket, 2, big ticket. If speed is 60 or less, the result is 0. If speed is between 61 and 80 inclusive, the result is 1. If speed is 81 or more, the result is 2. Unless it's your birthday, on that day your speed can be 5 higher in all cases. Okay, so this looks like a basic branching range type problem that we've been doing before, but they've also got the exception of the if it's your birthday or not, and that's going to be changing the values by 5. I think one of the ways we can do this is we will just use is birthday. Let me see. Obviously we could do the entire tree with the is birthday as being true and then write the whole thing over again with is birthday false. But then we're basically solving the whole problem twice. So we're trying to be a little more succinct than that. Let me see. So what we can do is we can put an integer in here, int adjust, and we're going to go ahead and int adjust, and we're going to make it 0. And then if is birthday, birthday. If is birthday, then we're going to set adjust, assign that a value of 5. Okay, and then we're going to set up the problem. And we're just going to use that adjustment there. Let me see. So if so no ticket if speed is 60 or less. So if speed is less than or equal to 60, we're going to return 0 for no ticket. But what if it's your birthday? Well, if it is equal to or less than 60 plus adjust. Okay, and what that's going to do is we've got our adjust. So if it's not your birthday, then 60 plus adjust is just 60, right? But if it is your birthday, then 60 plus adjust is going to be 65. So it's increased that. And then we're just going to kind of go, let me see, else if speed is less than or equal to, let me see, less than or equal to 61 plus adjust, and speed is less than or equal to, oops, greater than, oh, actually it's greater than or equal to 61. Greater than or equal to 61 plus adjust, and speed is less than or equal to 81. Oh, it's be 80 inclusive plus adjust. And then would be return 1. That's the small ticket. And otherwise it would be a large ticket, so return 2. That should do it. Yep, there we go. So see this without the adjust thing, we would basically be writing this entire code block twice. One for birthday, one for not birthday, with slightly different values. The whole point of programming a lot of times is to make those adjustments, so to speak, on the fly there, so you don't have to do things like that manually. So do not repeat yourself. Dry programming. Alright, I think we're going to go ahead and wrap this up now, and we'll be picking up after CaughtSpeeding sort of some next time. Thanks for tuning in, guys. Appreciate you. Comments, of course. Comments, questions, requests are welcome. Like, subscribe, and I'll see you guys next time. Bye-bye.